Alright guys, I'm back talking about trapezoids again, part 3. So like I said, we're going to take this trapezoid, draw a diagonal in, and actually cut it into, as you can see, two triangles. We're going to again show the area of a trapezoid is actually the sum of two triangles. So I'm going to call, and as you remember back to your mid-segment formula, which we'll get into a little bit here, which I think is on your paper. It says what's a mid-segment. We'll talk about that, or I'll talk about that in a moment here. But remember, trapezoids have two bases. So I'm going to call one of these B1 and one of these B2. And as you can see, one of these bases is the base of one of the triangles. The other base is the base of the other triangle. So you got B1 and B2 are your two triangle bases. There is a couple things they share. Now you're going to see they share this sort of side over here, but they also share a height. If you think of it, this altitude that I'm going to draw in here, and that you should draw in, is the height of either one of these triangles. Obviously you can see it's the height of the yellow triangle. It's also the height of this bluish triangle over here. If you were to draw this altitude, it'd be hard to draw it inside the triangle, but if you were to measure the height of this, it's kind of weird that an altitude can be drawn outside the triangle, but this height would be the same. And you can draw altitudes outside a triangle. It is valid to do that. So these both have the same h, the same height. So if I want to find the area of this entire triangle, this entire trapezoid, I'm going to find the area of this triangle and add it onto the area of this triangle. So again, we're doing 1/2 base times height. The area of the yellow one would be 1/2 B2, this entire B2 times that height. The area of the top one would look exactly the same, except it would have B1 in there. So, and again, it's a little weird to see base 1 and the height is actually this altitude that would actually go through or go from this point to the top base. That's the area of a trapezoid. Now it has not been cleaned up. We're going to clean it up a little bit. If you look, we've got some like terms on there. You can think of combining like terms, but it's really going to be a factoring step. Look at these two things. What do you have in common? What can you factor out of there? What greatest common factors can you factor out? And hopefully you're thinking the 1/2 can factor out. Hopefully you see the h can factor out. So this is one version. You don't have to copy it down yet. This is one version of it where the 1/2 has been factored out of this garbage and the h has been factored out. I think this is your textbook's version. I don't like this version because I like thinking about it in terms of mid-segments. I like this version where I just put the h at the end. This to me makes more sense. 1/2 times base 1 times base 2. You've done this before. What's it called when you add the bases together and divide by 2? Hopefully you remember, oh, that's the mid-segment. That's the segment that goes across here, that cuts this trapezoid in half. I like to use that. It's really the mid-segment, and I think I'll show that as well on here. It's the mid-segment times the height. And the reason I like this one better, or this one better, like these two better than this one up here, I like to think of it as base times height. Anytime people talk about area, we like to think of it as base times height. Well, a trapezoid has two different bases, so before you can do base times height, you've got to find the average of the bases times the height. This is my favorite version. I've seen some people love this one. They go, oh, average of the bases, that's the mid-segment. I'm going to do the mid-segment times the height, and you certainly can do that. And I think it's on your paper. It says, what's a mid-segment? If you refresh your memory, a mid-segment connects the midpoints of the legs of a trapezoid. So it's and another way to say this is the average of the two base lengths. It'd be a side that's parallel to the bases and the average of their lengths. So pick one of these three to be good at. You do not need to know all three of them. Here's my favorite. I've seen certain students love this one. And some people like the textbook version of it, which is the top one. To me, this is a little bit backwards. I like to do the average of the bases first and multiply by the height. But just don't forget there's a 1/2 somewhere in that formula. So, go for it. Throw a couple trapezoids at you on the bottom. I've got 5 of them on there. And so that first one, so these are trapezoids. It's given up here in the directions. You do not need more information for that one. I know some of you are going, well, I want to know this bottom side here. And you're trying to be greedy with me. No. You can figure it out. You've got the trig skills. You've got the Pythagorean theorem skills. You could sketch in some more segments on there to help yourself. I'm going to go back a second here. As you saw, the 12 came up here. All you'd have to do is cut this trapezoid into two shapes here. If you drew this segment in here, you'd have a side length that would take 11 off of this. This would be 11. Sorry, not my pen would be 11, but this little piece would be 11. And above that would leave 9. If this is 9 and that's 15, you can either see it's a Pythagorean triple or do Pythagorean theorem. 9 squared plus h squared, because this is actually going to be the height of the trapezoid, which is a little tricky, equals 15 squared, and you'd eventually get 12. Now, you can copy that down if you want, but I want you to realize you'd have to be able to find that on your own a lot of times by drawing in the altitude. Again, the altitude's going sideways here because this trapezoid's been spun around. The bases are actually the left and the right. Again, base does not mean bottom. It could mean left and right. It's the ones that are parallel in this case, are the bases. So these are the bases, 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 bases. This one, the bases are left and right. Keep an eye out for bases that are turned sideways on here. So you should be able to find area of all these trapezoids on the top, these top 3. I would strongly suggest you pause it and attack from there. You'll notice you have to find the height on a few of these, just like I kind of talked about here with finding this 12. Kind of talked you through that one before it really came up here a little bit. But go for it. You might find extra information on here for some of these. Hopefully this one you realize, oh, there's base 1, there's base 2. Add those together, divide it by 2, and then multiply by the height. You may see one of these sides is, other than finding the 12, you don't need the 15. So hopefully, and it does say, I think on your paper it says find the mid segment as well as the area. The mid segment is adding these up and dividing by 2. It's a segment that would cut through here. Multiply that by the height of the trapezoid, multiply that by 12, and I think you get 186 square units. One in the middle of your page. Again, you're going to have to draw altitudes on here. That's sort of the skill that relates Pythagorean theorem to all this. If you draw this altitude in, kind of in the middle here, I believe it ends up being 6.43. I can label it here, or I can label it over here. It's the same thing on both of them. Again, at this point, you should be pretty good at using a sine ratio to find that. I'm hoping by now that's not easy for you, but pretty straightforward. And you got to be careful with how you interpret that now. That 6.43 or 6.43 is the height. The base is this entire thing. Or sorry, one of the bases is this entire thing. The other base is 10. Think about this entire length down here. This is probably obvious. This one here should be 10 units long. Think about how you're going to find just this piece of it. It's another trig ratio. Maybe using Pythagorean theorem. Probably going to use cosine to get this. This is adjacent over hypotenuse. You're probably going to use a cosine ratio to just get a little piece right there. I believe this little piece is 7.66 something something something. If you add that entire thing together, the 10 plus the 7.66, this entire base is 17.66. That's a tricky step for some of you the first time you see it. Again, that comes from, this is 10, so this is also 10, because I drew an altitude. This is a cosine ratio to get me that little side length there. It should get you 17.66 when you add those two values together at the end. So now you're actually ready to actually use the formula. That's all just front end work, realizing you have to find base 1. You've got to find the height, and now you got the other base 2 on there. I think the area for that one ends up being, mid segment ends up being around 13.8, which is the average of these two. And I believe the area ends up being about 88.9 square units. All right. Third trapezoid on there, again, you're going to sketch in an altitude. And if you like your ratios, that might be an easy way to do it. We did one kind of like this on the front. We had a hypotenuse of 10 and a special right triangle here. I think you remember this was 5 rad 2 and this is 5 rad 2. You certainly could use sine and cosine to get those. If you're trying to get the height, I think you'd use sine. 45 is, the height is opposite to 45. If you're trying to find this little wing down here, this little piece down here, you're probably going to use cosine. Of course, remember, these are the same. These are going to be equal. Even though they don't look equal on my screen up here, they should be equal in length. I think you get around 7.07 in terms of a decimal for both of those values. Now think about this for a second. Maybe draw it on your paper. If you were to draw both of these little wings of the trapezoid on here, they got to be, it's an isosceles trapezoid. They'd have to be the same. So both of these little pieces is around 7 units. Think about how long this little piece is here. That, of course, is also going to be 8. So that entire length of base 1 or base 2, whichever one you call this, is 7 plus 8, which gives you a mid-segment of 15.07. If you were to add these together, add it to base 1 and divide by 2, you get around 15.07. And you multiply by the height, you should get around 106 square units for the area of that figure. So I think, these are kind of upper level questions. A little bit tricky. You got a trig application and 2 different lengths on there. I'm not giving you enough of the basics of that formula to work from. All right, last 2 on here. This one you're going to answer in terms of x. This one you're going to actually be able to find a solid value for that. And I'm not giving you anything more on that one. Kind of like these, you got to draw an altitude. If you know your 30-60-90 ratios, life might be a little easier, a little quicker for you. But again, you probably should pause it and try it on your own. The question I often get for this one is, are we finding the area of this little piece over here? No, it's finding the area of just this green trapezoid. So this is just to help you get a dimension over here. And this little piece is 2x, the top base is 2x, the bottom base is 6x, this side length is 4x, this altitude over here is 3x. You'll answer that in terms of x. So the mid-segment, of course, is adding these together. 4x divided by 2, and you should get 4x. And the other piece of that, I guess I didn't put it up here, but so the mid-segment should be 4x on here. This is the height. So 4x times 3x, it's not 12x, it's 12x squared. And I know some people get confused. This is the area. I should put units squared at the end of that as well. X squared has nothing to do with the units. X squared is just some variable squared. It has to do with the scale of how big this trapezoid is. So this is not the units. This is 12, and x times x, or x squared. And again, the mid-segment should be 4x on that one. For the last one, hopefully you drew in that little altitude on there. If you know your 30-60-90 ratios, this is a lot quicker if you know 30-60-90 ratios. This is 12. Think about how long that one is. It's a really quick one. This is 12. That should be 6. And of course, that 6 is the height of the trapezoid. And if you want to find this one, you can use trig and get some decimal values. Or you can just do 6 times rad 3 and get this little piece. And of course, you know this piece is also going to be 10 because above it is 10. So I believe that entire length of this entire thing is around 20.39. And again, at any time you should be thinking about pausing this. If you're just copying these numbers down, there's pretty much no value in this PowerPoint other than making you better at copying things down. I'd work through these ahead of time and try to pause and go, wait, did I get this? Did I get that value? Hopefully you get a mid-segment on there of around 15.2. That's, again, adding the 20.39 plus the 10 and divide by 2. And I think then you multiply this by your height by 6, and you should get around 91.2 square units. So the last one I've got on your paper, just a little word problem. This is kind of the end of the given shape problems. This last one, there's no figure drawn. You got some blanks to fill in on your paper. You got a trapezoid with an area of 85 square inches, a height of 5 inches, and one base has a length of 12 inches. And you can work this problem in any order you want, but you are trying to find the length of the mid-segment and the other base. And you can do it in either order. You can go for the other base first, go for the mid-segment. I personally like to do a sketch first. I would suggest you pause this one and think for a little bit. This is a good one to think about. You want to take a few minutes to work through.